Hello everyone, welcome in Learn CHE. Here we are with our new video and today we are going to discuss about distillation, right? So this is very important for the mass transfer operation. Okay, in mass transfer I think distillation is very important. So in this video we are going to discuss about what is distillation. Then we will discuss about the examples of distillation. Then we will see the methods of distillation, right? Which type of methods are used to perform distillation. Then we will discuss about the types of distillation, right? So in the types of distillation, I'll give you the overview of batch distillation, continuous distillation, flash distillation, azeotropic and extractive distillation, as well as steam distillation. Okay, in the types of distillation we will see the overview of all the distillation which is written here. Then in our next video we will cover each distillation in a separate video and we will see the derivation as well as the numericals of that distillation. Or in our next video we will first discuss about the vapor liquid equilibrium, right? So before starting the video, if you haven't joined the Learn CHE YouTube channel, please subscribe it and hit the bell icon so you could get the latest video of Learn CHE. So what is distillation? So distillation is a unit operation. First thing, distillation is a unit operation and we can say chemical operation, not chemical reaction. I am saying that it is a unit operation as well as chemical operation. And distillation is defined as separation method which is used to separate the more volatile components from less volatile one from the feed mixture. Okay, suppose we have any feed mixture and in that feed mixture we separate the more volatile components from the less volatile components with the help of partial vaporization, right? And after that partial vaporization, what we do? We do the condensation so that we could get our product in the form of liquid. Okay, so this is the first point. Now the second point is separation by distillation is based on the difference in volatilities of mixture or difference in vapor pressure of different constituents at the same temperature. What does that mean? This is our distillation column, okay, and here we are supplying the crude oil. Okay, suppose we are assuming that this distillation is deployed in a petroleum industry, right? And this is our feed plate. This is our feed plate and this black one arrow which is going downward, this is the liquid. This is a liquid and this one is a red one is a vapor which is going upward. Okay, if you have a feed mixture that is in a liquid form, that is a liquid mixture, okay, that liquid mixture may be a preheated and when it goes into the feed plate and from the bottom side we have also used a reboiler. Okay, reboiler is also used to supply the heat. So what happens that this liquid is vaporized and the vapor goes upward. Okay, and when the vapor goes upward and here as we go upward, so temperature decreases. As we go upward, temperature decreases, right? So what will happen that as the temperature decreases, so some amount of vapor will convert into the liquid and it will goes down, right? So as we have to get or we want more volatile component from the less volatile component, so there should be something after that we get. This means here is a crude oil, okay, and after the distillation process we are getting gases as well as residues from the bottom, and here we are suppose we are also getting x1, x2, x3, x4 and x5 product. Okay, and suppose if this is a petroleum, so we may simply say that we are getting from here naphtha, diesel, kerosene, lubricating oil, wax, these type of products. Okay, this x1, x2, x3 may be this. So how we are getting from the top gases and how we are getting here x1, x2, x3, x4, x5 and in the last we are getting residue. How? It is depend upon the vapor pressure, okay, vapor pressure of the mixture as well as on the boiling point, you may also say. What is that mean? It means that the gas will have different vapor pressure Okay, this x1, this x2, this x3, this x4 will have different vapor pressure as well as different boiling point, right? Because of this difference, we get different fraction from different region of the distillation column. Okay, and this process is known as the fractionation distillation, right? And in the this distillation column, the feed plate, okay, above this feed plate is known as the rectification section, and below this feed plate is known as the stripping section, right? And here the reboiler is placed or deployed here, and here the condenser is used in this side, right? So now we go ahead, and here is in distillation phases involved are vapor and liquid. Obviously, when we supply the liquid mixture, so liquid mixture is converted into the vapor plus liquid, right? And from the top we get the gases like LPG, so that is in the form of vapor, and from the bottom and in the mid we get the liquid mixture. Okay, now here is the point is mass transferred occur between both the phases means liquid to vapor and vapor to liquid. How? Just see that in this diagram we can see that liquid is converting into the vapor. Okay, our liquid is converting into the vapor. How? This is done by the vaporization, right? And vapor is converted into the liquid. How? When from here our vapor goes out from the distillation column, then it goes into the condenser. Okay, in condenser vapor is converted into the liquid. Okay, so vapor convert into the liquid with the help of condensation, right? And mass transfer occur between the phases means liquid to vapor as well as vapor to liquid as well, right? So this is very important while understanding about the distillation. If you know that, so in the upcoming videos and upcoming topics of the distillation you can understood easily. Then here the last point is more volatile component, that is mainly vapor, will be higher in the vapor phase definitely, and the less volatile component, that is we can say the residue component, will be higher in the liquid phase region. Okay, so let's see in the figure. Here you can say that more volatile component will simply go upward, right? It will go upward, and in this section there is a vapor phase, mainly there is a vapor phase, and in this section there is a stripping section, there is a liquid phase, and in this liquid phase we have less volatile component. Okay, the composition of less volatile component is higher. I hope you got this. Okay, now if the vapor composition, okay, vapor composition, suppose V is same as the liquid composition, suppose it is same as the L in the distillation column, then distillation technique will not effective for separation, then we may use. Okay, what is that mean? It means that as we discussed that distillation or the separation by distillation is based on the difference. Okay, difference in volatilities of the mixture, difference in vapor pressure. Okay, when there will not be the difference, then what will happen? Then distillation will not be the effective process. Okay, in this diagram when there is no difference, okay, so this crude oil will not be distilled, or and it will not convert into the different fractions. Then what process we will use, okay, and what mass transfer operation we will use, please let me in the comments box. Okay, I hope you understood that what is distillation, why we use distillation. Okay, we will discuss this. Now let's see the examples of distillation. Okay, so the first example in refinery. Okay, in refinery we get the different fractions of components from the liquid mixture or from the crude oil. Okay, and you have seen in the picture that we process the crude oil, and that crude oil by the distillation we get the different fractions. We are getting gases, then naphtha, after that kerosene, then diesel, lubricating oils, waxes, okay, bitumen, then there is a residue. And so these all the types of fractions which we are getting, this is we are getting because of the distillation. Okay, and this process is very prominent in the refinery. Now the second example is salt water is turned into the fresh water through distillation. Okay, this is another example of distillation. Now the third example is separation or recovery of ethanol from its solution in water in the process of manufacturing of alcohol. How we do that? We do that because of the difference in boiling point, right? Because we have a mixture, and when we supply the heat and we have a proper arrangement, then we could get our ethanol from the water, and this process is known as the distillation. Now the fourth example is here, that is alcoholic beverages are made through the distillation process. Same here. So we have the 4 examples here of distillation. Please let me in the comments box another example of distillation which you have seen in your daily life as well as in the industry. Now why distillation is very important in the industry? So the one reason is distillation is used to enhance the purity of the desired product. We will see this in our upcoming videos, how distillation improve the purity of the product. Okay, and here is one example. The example is, this is our diagram. Okay, in this diagram vapors goes upward. Okay, and after that it went into the condenser. Okay, after the condenser some amount of liquid mixture went into the first tray of the distillation column, and remaining part is collected in the accumulator. Suppose this is a accumulator. So this liquid mixture is known as the reflux. Okay, and why we use this reflux? We use this reflux to enhance the purity of the fractions. Okay, so that's why distillation is also used to improve the purity of the desired product. When our desired product will be more efficient or more pure, then we can use it in a better manner. Okay, and here are another example of purity is that drying of commercial benzene, okay, from the removal of traces of water present in it. Okay, in the commercial benzene there is a traces of water present in it. Okay, and with the help of distillation we improve its quality. Okay, and why? Because commercial distillation is our desired product. So this is also a example of distillation. Okay, so as I have already told you that distillation is a unit operation, and this is very important unit operation in an industry. When you will go into the industry and in mass transfer, you will see that the distillation has a very wide coverage. Okay, and because of its importance in the industry, okay, it may be a chemical industry or it may be a non-chemical industry, you may see the distillation process. So because of its importance, distillation is called the workhouse of the chemical industry. Okay, because this distillation process is very prominent. As I have told you, in refinery, without distillation we cannot imagine the different fractions from the crude oil. Okay, so that's why distillation is known as the workhouse of the chemical industry. Now we will discuss about the method of distillation. So method of distillation is depend on the different factors. Like it also depends upon the desired product, which type of desired product we want. Is we want the higher purity product or we want the medium purity product? Okay, which type of work and where we have to use that product? Okay, and as well as the mixture, which type of mixture we are dealing, and what is our aim. As I told you, which type of product we have to use for the further process. Distillation is carried out in 2 ways. Here is the first way. Is in the first way, what we do, the vapor formed by the heating the liquid mixture is condensed in the condenser, and a part of the condensed liquid is returned to the first tray of the distillation column, as I have told you, and this part of the condensed vapor which returned to the distillation column is known as the reflux, right? And this operation is known as the rectification or fractionation, and the remaining part is withdrawn as a product. And we can also say this is a, and in this process we use a reflux. Why we use this reflux? To improve the quality of the product and to enhance the purity. Okay, now the second is, the liquid mixture is to be separated is heated, okay, to create the vapor, right? Then vapors are condensed in a condenser and withdraw as a product. Here we are not using reflux, okay? Then as there is no reflux, product is obtained from the top of the column, hence the obtained product is less pure. You can see here. So this type of operation also we use in an industry where we do not use the reflux. Okay, why we are not using reflux? Because we have to also reduce the cost. Okay, when we will use reflux, so simply the cost of the operation will also increase. So these two types of operations or method we mainly use to perform the distillation. Right now we will discuss about the types of distillation mainly which you will see in the industry. So here I have written 6 types of distillation, and in this video today I'll give you the overview of all the 6 types of distillation, and in our upcoming videos we will discuss each distillation thoroughly. So our first distillation is batch distillation. Okay, I think you know about the batch. What is the meaning of batch? Okay, so whenever we have to use or we want any product in a less quantity, okay, and in limited quantity, so we use a distillation product. Okay, distillation means separation. Okay, so whenever we use this product in a, you can say in a small level, so we use a batch distillation mainly in a laboratory. Okay, whenever we have to research something, okay, research related to separation or distillation, we use a batch distillation. This batch distillation is also known as the differential distillation, simple distillation, or Rayleigh distillation. Okay, in this batch distillation you will study about the Rayleigh equation. Okay, so this is about the batch distillation, and its example is also limited, okay, like in laboratory and in pharma as well, because in pharma we mainly research in the R&D, so where we use the batch distillation. Next one is flash distillation. So flash distillation is also known as the equilibrium distillation. In this distillation, what we do, we mainly partially vaporize the liquid mixture, and after that liquid and vapor are allowed to attain the equilibrium. Okay, and after that we get the our desired product from the top and residue or the liquid from the bottom, and this is also very important. And after that there is a fractionation or fractional distillation. Okay, this is also known as the rectification, fractionation, distillation. Okay, so in this distillation we get the different fractions of product, like in refinery get the LPG, then other fractions like we can discuss about it, like naphtha, then kerosene, diesel, lubricating oil, waxes. Then in suppose this is a our atmospheric distillation unit, then we send our residue into the vacuum distillation unit. So in the fractional distillation we get the multi fractions from the mixture of crude oil. Okay, so this is our fractional distillation. And after that there is the fourth one is azeotropic distillation. Okay, what is the azeotropic distillation? Okay, so azeotropic distillation and extractive distillation, these both distillation are used when the ordinary distillation method, means batch, flash, fractional distillation, are not used, okay, for that mixture. Okay, why? Because the boiling point, okay, the difference in boiling point is very less. So for that mixture, okay, and for that mixture we use the azeotropic and extractive distillation after adding the one more component. Okay, and that more component is act as a solvent. Okay, and we will discuss about it in our upcoming videos. Okay, and here is the last one is steam distillation. So why we use steam distillation? Steam distillation, here we use steam, or we can say the live steam. Okay, and it is a process in which steam is in direct contact with distillating system. Are you getting my point? What I want to say here, we are using steam as a hot, you can say, the medium, and with steam distillation, okay, and with steam distillation it is possible to separate the substance at a temperature lower than their normal boiling point. Okay, and this is not done by the our ordinary distillation. That's why we use steam distillation, and steam distillation may be used as a batch wise or as a continuous wise. It depends upon our aim or our nature of work, right? So today we discuss about the types of distillation, then we discuss about the method of distillation, examples of distillation, and I think you understood about the what is distillation basically. Okay, if you have understood what is distillation, then I think distillation is not tough for you. And in our next video we will discuss about the vapor liquid equilibrium diagram. Okay, here you are seeing the diagram. This diagram is an example of batch distillation. Okay, and I think I do not need to tell you why this is batch distillation, because this apparatus you will mainly see in a laboratory or in R&D, right? So this is a batch distillation example. So thank you for watching. See you soon.